Now, we're going to be looking at some algebraic fractions involved in equations here. But I want to make a really important distinction from a previous technique that we've learned. This is not a fraction equals fraction situation. You'll notice, for example, for part A, we've got two fractions added together equal to a whole number over here. Now, we did talk about some techniques of manipulating this to be a fraction equals fraction situation, but we are going to be talking about a generalized technique that works here. Now, the biggest thing to keep in mind is we want to, if we've got two fractions with each other on a side of the equation, we want to amalgamate those or squish those together to be one fraction. It makes solving so much easier because we've solved lots of equations that have looked like that before, so we know the technique to be able to solve that. So, for now, that 7 is not going to be involved. Now, I'm going to be a little bit cheeky and put my equal signs over here because I need a bit of room for activities over here. So, we can, for now, ignore that 7. We're definitely going to revisit it, don't worry. We're just going to be zooming in on these two fractions here. Now, in order to make them one fraction, the technique we need to use is lowest common denominator. Thinking about what we've got here, and like we spoke about a lot in algebra, the lowest common denominator is going to be 6. So we need to multiply the top and bottom of this fraction by 2, and the top and bottom of the next fraction by 3. So that means we're going to have a big old vinculum on the left-hand side with 6. Then we're going to have 2x times 2 is going to give us 4x. Plus is coming from here, so we're just dragging that down. And then x times 3 is going to be 3x. Like always, if we can put together some like terms, we deal with that before we continue solving. So 7x over 6 equals 7. Now, we've solved a lot of equations like this before. We're going to multiply both sides by 6. So 7x is going to equal 42. And now we'll divide by 7. X is just going to be 6. So the strategy with this, we want to make a single fraction. So make a single fraction. This was on the left-hand side, so I'm going to write on LHS. Then going from the next step, we dealt with like terms. After we'd made a single fraction on the left-hand side and dealt with like terms, we'd arrived at an equation that we're really familiar with solving. So that's the main technique. Let's apply it to a few different scenarios. Okay, looking at this question, we have a fraction plus a fraction equals 1. So let's use the technique of jamming together these two fractions by using lowest common denominator. In order to do that, observing what we've got, a 5 and a 2, the lowest common denominator is going to be 10. Now, this one, you'll recall from algebra, we needed to put brackets around when we had more than one term. Because we're going to be multiplying numbers by that, we want both numbers involved. So the top and bottom of the first one is going to be multiplied by 2. So times 2 times 2. The top and bottom of the second one is going to be multiplied by 5. So how are we going to do that? Times 5 times 5. So that equals 1 is just going to hang out waiting to be involved. So I might just put it there. And now let's put our big old vinculum with our lowest common denominator of 10. So we're going to have 2 and then in brackets a plus 2 because that represents 2 times the entirety of a plus 2. This plus sign goes down here. And rather than writing the 5 at the end, we traditionally write the 5 in front of the brackets. This said 5. So 5 and then in brackets a minus 3. A little bit squishy in the end. Alrighty. So now that we're at this point in our solving process, you've got a few options about what you'd like to do. I sort of want to deal with the fact that these brackets are here, so I'm going to expand out this bracket and then expand out this bracket and deal with the rest of the solving process a little bit later. Okay. Sorry, I keep accidentally tapping the microphone with my pen. I've got a new setup going on. I'm not sure I like it. Okay, so expanding those brackets. 2 times a is 2a. 2 times 2 is 4. Plus 5a minus 15. It is important to notice, here we're doing positive 5. I like to scoop up that sign with that number. So positive 5 times a gives us 5a, positive 5 times negative 3 gives us negative 15. And that's still over 10. Let's deal with those common factors that we have here. Not common factors, like terms. So we've got 2a plus 5a will be 7a plus, oh, I've been a bit presumptuous here. So I did the 2a plus 5a to give us 7a. Now we've got to do just the numbers. I've got 4a minus 15. Well, it's actually going to be minus here. So you could write minus, because we're going to have positive 4 minus 15 will be negative 11. But ideally, let's write that as just a negative there. If you wrote plus minus, you can deal with it in the next line. So that equals 1 still. Okay, so what have we done? We've made into a single fraction on left hand side. Then what did we do? Oh, I wanted that arrow to be red. Then what did we do? Then we expanded. After we did that, we dealt with like terms. And after we've done those few steps, now we can just solve. Solve as normal. So let's actually do that. We're going to multiply both sides by 10. So 7a minus 11 is going to equal 1 times 10 is 10. We're going to add that 11 to both sides. 7a is going to be 21. Then we'll divide by 7. A is just 3. Now remember with these, you could always go back and check whether these answers are correct using the strategy we spoke about in a previous lesson. Let's apply this to a few more examples, and what I'm going to say is you must be very careful with your negatives here, because I noticed this one has a negative in between. So we're going to do our first step of making a big old fraction on that left-hand side, just because that's where all the fractions are. And that minus 1 is just going to hang out waiting to join in. So, bracket, 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 bracket. Lowest common denominator is going to be 6, so we're going to have to do times by 2, times by 2. And on this side, times by 3, times by 3. We've got a nice common denominator of 6 now. So that 2, and then in brackets a minus 2, goes there. This negative sign here is what goes in between. Now that negative causes a lot of issues if we're not careful. So we're going to pay extra special attention to that. Then we've got 3a plus 3 all times 3, and the way we show that algebraically is by putting brackets around it and putting the number at the front. Okay, let's deal with the fact that we've got some expansion to do. So we'll expand and expand, keeping in mind for this second one, we're not just multiplying by 3, we're going to be multiplying by negative 3. So that first one becomes 2a minus 4. Let's maybe put that big old vinculum ready to go. And then minus 3 times 3a will be minus 9a. Minus 3 times positive 3 minus 9. And that still equals negative 1. Okay, so I realized I made an error when I was going through this. I said negative 1, but I didn't actually make that negative 1. So let's go through and fix what I did. So now let's deal with the fact that we have some like terms here. So we've got 2a minus 9a is going to be minus 7a, and negative 4 minus 9 is going to be negative 13, and that's going to be equal to negative 1. So now that we've dealt with all that, we can solve like normal. We're going to multiply both sides by 6. So minus 7a minus 13 is going to equal negative 6. We're going to add 13 to that. So minus 7a is going to be negative 6 plus 13. We could think of 13 minus 6. So that's going to be 7. There we go. And then divided by negative 7. A is going to equal negative 1, because a positive divided by a negative means our overall answer is negative. Okay, another situation where we've got two fractions on the left-hand side. Be careful, we have a negative sign around them. So I'm going to show you, like I did in the last example, it's really, really important to show this step here. this step is the one that I see students most frequently skip, and it's the ones that then, as a result of that, students tend to make the most errors, mainly because they tend to get the sign of this number wrong. So let's make sure we're doing that step here. Going back to my black pen. Okay, we need brackets around these because we're going to have a common denominator. And looking at those numbers, our common denominator is going to be 10. To achieve that, we need to multiply the top and bottom of this times 2, and the top and bottom of the second one times 5. But minus 5 on the right-hand side is still just waiting to join in. So because I'm scared of making, not scared, I'm nervous that I might make another error with my sign, so I've written that number down straight away, just so I don't make any silly mistakes. It's not silly in that I'm silly, it's silly because there's so much our brain is trying to do. So let's make it easier for ourselves and write that down early on. Okay, so then we've got 2 and then 4 minus x. This negative sign has come from here, and then we're going to have 5x minus 1. If vinculum's too short, just make it a little longer. Let's expand out. 8 minus 2x. And then we've got, here's the big one, minus 5 times that x will be minus 5x. Minus 5 times that negative 1 is going to be positive 5. This is the kicker, and where students tend to make the most errors. Okay, that big old vinculum of 10 equals minus 5. Now, we like to neaten up things here in terms of if we've got some like terms. So let's do that. So we've got that minus 2x minus 5x, that's minus 7x. And then we've got this 8 and this plus 5. So let's put that together as plus 13. Still on 10 equals minus 5. Now we're going to solve as normal. Times 10 minus 7x plus 13 will equal minus 50. We'll take away that 13. Minus 7x is going to be minus 63. If we divide by negative 7, x equals 63 divided by 7 is 9. Negative divided by negative is a positive. Now remember, we happen to have had some whole numbers as our past answers for the last few questions. You can get a fraction, negative or positive, and sometimes you can even get x equals 0. So just be aware our answers can look like all sorts of things. Okay, last two examples here. This one's a little different because if we look at our denominators on the bottom here, the lowest common denominator is actually going to be 10. So that means we only need to multiply the top and bottom of this fraction by 2. I still recommend, for reasons you'll see soon, put brackets around both of those numerators. They both have more than one term in there, and you're going to see, like we talked about in algebra, the brackets around the second numerator are going to be extraordinarily important. Okay, vinculum 10 equals negative 2. Then 2 bracket 3x plus 3. Here's the kicker. This negative goes down here, and that negative acts on both the x and the plus 1. That's why we needed brackets around that one. Omitting brackets means we haven't let that negative influence both the x and the positive 1. So now we'll expand. Expanding that second bracket, it's like there's an invisible negative 1 here. So it becomes minus x minus 1. Let's clean up those like terms. Now we'll solve as normal. Whoops, looking at my question here, I did negative 25 divided by 5. We've got to be careful of our signs. That's negative 5. Okay, let's look at that next one. Oh, last example. Now, this one is really exciting. This situation, we have fraction minus fraction on the left-hand side. So let's sort out getting that into a single fraction, and then we'll talk about the cool technique we can use here. So what we're going to do is we're going to We're going to leave that x minus 3 on 2. We're going to leave the right-hand side of this equation. Just focus on getting that left-hand side as a single fraction, and then we'll talk about, like I've mentioned before, the strategy we can use. Brackets around everything. Lowest common denominator is going to be 12. This negative sign has come from here. And remember, we always put the number at the front of the brackets. Now we're going to expand out the brackets, collect any like terms, leaving that left-hand side just waiting to join in a little bit later. Sorry, right-hand side. Oh goodness, I think I was talking to myself and not recording. So, like I was saying to myself moments ago, we've gathered together our like terms. So with that minus 8x minus 6x, we've got minus 14x. 4 minus 12 gives us that negative 8, and that's all over that denominator of 12. Now, in this situation here, we have found ourselves in a pretty exciting predicament. We now have a fraction equal to a fraction. So that means we can use our cross-multiplying technique. So we'll install some brackets here. We're going to multiply this 12 over here, multiply this 2 over here. It's 14x minus 8 equals, and then 12x minus 3. Expanding things out. And now we're going to solve that as normal. I have not given myself a huge amount of room here, but that's okay. I'm going to skip over this, and we'll continue working down here. Although this required a few lines of working out, and perhaps you'll find with a bit of practice you can do fewer lines, although don't cut it down too much because, again, too many calculations happening in your head at once, you're likely to make a little error there. But working on this all the way through, you might have had a slightly different way of working it out, but provided what you've done is mathematically correct and your answer has got a half there, and you haven't done any, mistakes that undid other mistakes to get the right answer. That's a really nice strategy there. So what we did in all of these examples, when we had more than one fraction on a side of the equation, we tried to squish them together, but more formally, what I mean by that is we found the lowest common denominator and we added or subtracted the fractions depending on the question. It was only in this last example that we ended up in this line here with a fraction equals fraction situation where we could use the technique from last lesson. Remember, we always cancel down any fractions we have as our answer right at the end, so we can't leave it as 20 over 40, we needed to write that as a half. Really, really powerful strategy here. We're going to spend some time practicing this now. Good luck everyone, and let me know if you have questions.